Hello everyone, myself Preeti Ram, Assistant Professor in the Department of Computer Science and Business System from Ramco Institute of Technology, Rajapalayam. So today we are going to see the topic of random forest algorithm in machine learning. So the synapses are, now first we are going to see about the random forest definition, then the diagrammatic representation of the random forest, and then its working methodology. Then we are going to see about the relationship between decision tree and random forest, and also accompanying with we are going to see about the difference between decision tree and random forest. Then we are going to see about the real-time examples that we are going to apply it based on the random forest algorithm. So let's move on to the next slide. So random forest. So in simple, random forest is a popular machine learning algorithm that belongs to the supervised learning technique. It can be used for both classification and regression problems in machine learning. It is based on the concept of ensemble learning. So it is a process of combining the multiple classifiers to solve a complex problem and to improve the performance of a model. So it is a classifier that contains a number of decision tree on various subsets of the given data set and takes the average to improve the predictive accuracy of the data. So as the name suggests, instead of relying on one decision tree, the random forest takes the prediction from each tree and based on the majority votes of prediction, and it predicts the final output. The greatest number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. As we already know about the concept of overfitting, overfitting is in machine learning is when a model is trained too closely to the training dataset, making it unable to accurately predict the new data. This can happen when a model is too complex or trained for too long time. So random forest is used for both classification and regression. For example, classifying whether an email is a spam or not. Random forest is also used across many different industries, including banking, retail, and healthcare, and so on. So in this slide, we are going to discuss about the advantages of random forest. First one, it is an accuracy. So random forest are generally very accurate, especially for complex data sets. Second one, so robustness. Random forests are resistant to overfitting. So as we already discussed the topic about the overfitting in the previous slide also. So large data sets, third one. Random forests can handle large data sets effectively than comparing to the other algorithms. Missing values. Random forests can effectively manage those missing. Future importance. Random forests provide the future importance scores which can help with future selection and improve the model performance. So next one is the non-linear relationships. Random forests can handle non-linear relationships and interaction between the variables. So faster than bagging. Random forests are faster than bagging because each tree can only learn from a subset of its future. So better predictive performance. Random forests have a better predictive performance than regular bagging. So here we are learning about the new word name bagging. So its explanation can be discussed on the upcoming slides. So random forest algorithm can be saved and reused. Here is the diagrammatic representation of random forest. So by using some example, we can easily able to understand the diagrammatic representation. So now we are going to consider an example. So suppose there is a data set that contains multiple fruit images, for example. So which are we are going to give us a data samples. So this data set is given to a random forest classifier. The data set is divided into a number of subsets and given to each decision tree that it is we are going to consider as a future subset, that is S1, S2, S3, etc. to Sn. Here the given data samples are divided into a number of subsets for a future subsets that is mentioned as S1 to Sn. So then we are going to given it to a decision trees, number of decision trees, that is the tree 1, tree 2, tree 3, etc. to tree n. So during the training phase, each decision tree produces a prediction result, and when a new data point occurs, then based on the majority of the result, here we are mentioned as majority OT, which is the majority of the results, the random forest classifier predicts the final decision of those data samples. So also we can add one more example, that is the heart disease prediction. So we are going to give data samples related to the heart disease prediction. That is, we are going to consider some of the parameters based on our research purpose. So then we are going to divide it to a number of subsets, that is the future subset S1, S2, etc. to Sn. So for the more classification and for more processing, we are going to give it a decision tree, number of decision tree. We are using it a number of decision tree. Then we are going to separate it as a class 0 or class 1. So majority of the voting. So here we have 3 class 1. So the class 1 is majority. So we are going to take the final decision as class 1. That is the output of our algorithm. So which is the diagrammatic representation of the random forest. I hope you have understood very well. So then the working methodology of the random forest that I have already said in the previous one. So the steps are: step 1. So we are going to select a random samples from a given data or a training set. So second one is this algorithm, that is the random forest algorithm, will construct a decision tree for every training data. We have in the previous slide we have seen that the training data 1, training data 2, that we have separated into a tree 1, tree 2, etc. to tree n, which is considered here. So step 3, voting will take place by averaging the decision tree. So which is mentioned as in the previous slide, we have seen that class 1, class 0, class 1. We have seen 3 class 1 in the previous slide, which is the voting. So next one is finally select the most voter prediction results as a final prediction result. So based on the previous one, we know that class 1 is the majority of that. Then we will get a final prediction output result as a class 1. So working methodology of random forest that I have already said in the previous slide, we will know about the concept of bagging. So including that, we are going to also see about the boosting concept. So the combination of multiple models is called as an ensample. So ensample uses the two methods. First one is bagging and second one is boosting. So first one, bagging. So it is creating a different training subset from a sample training data with replacement is called as a bagging. The final output is based on the majority of the voting. So next one is the boosting. Combining weak learner into a strong learner by creating a sequential model such that final model has the highest accuracy, which is called as a boosting. For example, AdaBoost and XGBoost. So here we have included the concept of the decision tree algorithm. So that's why here we are going to know about what is the relationship between the random forest and decision tree. The random forest algorithm combines the output of multiple decision tree to generate the final output. This process of combining the output of multiple individual models is called as an ensemble learning. In this slide, we are going to discuss about the difference between decision tree and random forest. Initially, we are going with the definitions of both decision tree and random forest. In decision tree, a single tree-like model that splits data into branches based on the future conditions to make predictions or classifications. In random forest, an ensemble method that combines multiple decision tree to produce a more robust and accurate prediction by aggregating their outputs. Next one is the model structure. In decision tree, a single model with one structure prone to overfitting when the tree grows too deep. In random forest, a collection of a decision tree, each trained on a random subset of data and feature, reducing the risk of overfitting. Next one is the accuracy. In decision tree, it may not perform well on noisy or complex datasets, leading to lower accuracy. In random forest, generally it provides the higher accuracy due to averaging, which minimizes the variance and increases the generalization. So next one is the overfitting. In decision tree, more prone to overfitting, especially with deep trees. In random forest, less prone to overfitting due to the ensemble averaging effect. So next one is training time. In decision tree, faster to train as it involves building only one tree. In random forest, slower to train, but multiple trees are built and aggregated. Next one is our variance and bias. In decision tree, high variance as small changes in the data can lead to different trees. In random forest, it reduces the variance by averaging the multiple trees, resulting in more stable. So next one is the future importance. In decision tree, It can indicate the future importance but may overemphasize some futures. In random forest, it provides us a more reliable estimate of future importance since it aggregates the results across multiple trees. So in prediction method, in decision tree, the final prediction is determined by the path in the tree that the data follows. In random forest, the final prediction is obtained by majority voting, that is the classification, or averaging, that is represented as a regression of all tree in the forest. Complexity. In decision tree, simpler to interpret and visualize. In random forest, harder to interpret due to the large number of trees. So when to use the random forest and when to use the decision tree. In decision tree, it is useful for quick insights and understanding the simple relationships in data. In random forest, better for achieving the high accuracy and handling the complex or noisy data sets. Some points that explain why we have to use the random forest algorithm and when to use the random forest algorithm. That is, random forest takes less training time as compared to other algorithms. It also predicts the output with high accuracy. Even for the large dataset, it runs efficiently and effectively. It also maintains accuracy when a large proportion of data is missing. We have already know that the training phases and the working methodology of the random forest. In random forest works in the two phase. First is to create the random forest by combining n decision tree, and second is to make the prediction for each tree created in the first phase. Here is the some of the real-time examples of the random forest algorithm in machine learning. So the scenario we are used is the fraudulent transaction detection. So the problem statement is the banks and financial institution needs to identify the fraudulent transaction quickly and accurately from a large volume of the transaction data. So how the random forest is applied for the above scenario. First one is the data set. The data set includes the features such as the transaction amount, merchant category, and time of the transaction, location, device used, and customer history. These are the parameters that we are going to taken in our data set. Next one is the training phase. A random forest model is trained on the historical transaction data where each transaction is labeled as fraudulent or non-fraudulent. The algorithm creates the multiple decision tree using random subsets of the data and futures. Next step is the prediction. For a new transaction, each tree in the forest predicts whether it's a fraudulent or not. The forest aggregates the prediction, that is the majority voting, to make the final decision. The outcome. The model helps detect the fraud in real time, flagging suspicious transaction for further investigation while minimizing the false positives. Why random forest work well? So as I have already said in the advantages, so robustness to the noise, handles the noisy and imbalanced dataset common in the fraud detection effectively. Next one is the future importances, identifies as the key factors contributing the fraudulent behavior. Then one the scalability, works efficiently with the large datasets and many features. Next one is the accuracy. So combines the output of the multiple trees, reducing the overfitting and improving the generalization. Other real-time applications of random forest include healthcare, retail, and cybersecurity. In healthcare, diagnosing diseases based on the medical history and test results. In retail, predicting the customer product recommendation and check. Next one is the cybersecurity, identifying the malicious network activity. Also, it includes more real-time examples such as social media analyst, that is the sentiment analysis as we all know. Random forest can analyze the real-time social media post to classify as the sentiment, that is positive, negative, or neutral, helping the businesses understand public opinion or customer satisfaction. In energy sector, energy consuming forecasting, that is the random forest can predict the future energy consumption based pattern based on the historical data, weather forecast, and real-time sensor data, helping the energy providers optimizes the resource allocations. Also, it is used in the demand forecasting, that is in retail and inventory management. Retailers use the random forest to predict the demand for product in real time, allowing for efficient stock management and avoiding the overstocking or understocking. Likewise, there are numerous real-time examples of the random forest. I hope you have know more about the random forest in this video. Thank you. We will meet in another video. Thank you so much.